I think we are connected. Yeah, Professor, we are live. Welcome everyone in the webinar. My name is Vijay. I am co-founder of Mobilytics, and we build battery management solution for electric vehicles. I am your moderator for this session, and please feel free to post your questions in the right side chat box. Today we have Professor Ashok Jhunjhunwala with us. Professor Ashok Jhunjhunwala enjoys a phenomenal stature of reputation and excellence in the EV industry, and he is currently serving as an institute professor at IIT Madras. He is also nurturing several startups to develop battery packs and EV models. With that, over to you, Professor, for the presentation.
Okay, what I'll do, I'll share my screen and then we can just get started. It's a very short presentation. A basic tutorial on electric vehicles, that's what I was asked to do. I was asked that there will be students, for graduating students, and they may not know much about electric vehicles, but I do see a large number of you are from industry, so probably you already know everything about it, but let me just go through the presentation, and maybe as we spend more time on question and answer, we will get a better picture. Now, the first question that we normally ask is that why is there so much interest in electric vehicles? And if you look out of the window today and you see such a clean place, I mean, with everything else only looking bad today, one thing that looks good today is our towns and cities, because the pollution is gone. And actually, most of the pollution is due to the vehicle. I'll say vehicle, and number two, the construction industry is the primary contribution to the emission. And we believe that with electric vehicle, this pollution will actually go. The second important thing is that I have a curve here showing what is the amount of import of oil that we do. Actually, it is the import of oil which is crushing our economy. And we have been doing that year after year, increasing the amount of oil that we consume. And this is another thing that hopefully electric vehicles can actually remove. The basic fundamental things, if you do not know, the electric vehicle is actually 4 times as energy efficient as ICE vehicle. Internal combustion vehicle, and it has about 50 to even 100 times less moving parts, so it is far more reliable and 4 times as energy efficient. For example, ICE internal combustion engine efficiency, you can look at 22-23% versus electric vehicle where you can go 90% plus. So this is the primary thing, highly energy efficient, will save on energy. Now, where is the problem? The first problem is the energy density of lithium-ion battery cell. While it is continuously increasing, it has been increasing. It was barely 100 watt-hour per kg. Today, it is closer to 250 watt-hour per kg. This is for the cells. For the pack, the energy density will be lesser. But for petrol, it is about 9,000 watt-hour per kg. So if you see, there is even at the peak, 300 watt-hour per kg, we have a factor of 300. Now, 30, even if it takes this 4 times higher energy efficiency, we still are 8 to 9 times higher for battery rather than for petrol. So actually, instead of the petrol tank, we'll need the amount of petrol that we can hold, we'll need 8 to 9 times bigger sized battery, and both the size and the weight, and that is the primary problem. And therefore you'll have to actually often do with smaller range battery, and the smaller range battery is what is associated with what is called range anxiety. Number two, I think it's very important that the cost of the battery on the other hand is inversely related to energy density. For example, we today have a 250 watt-hour per kg. If you are able to get to 500 watt-hour per kg, the cost of battery is going to go down to half. Because higher energy density basically implies lower use of amount of materials like lithium, cobalt, nickel, and lower use of lithium, cobalt, nickel brings down the cost. Per kilowatt hour, it brings down the cost. Of course, so the push is to go towards higher energy density so that we can reduce the cost. But higher energy density has a problem that basically means it is uh, less safe. So it has a higher safety concern. Now, for example, if I look at the last 10, 11 years, the energy density has gone up from about 80 watt hour per kg for the cells to almost 310 watt hour per kg. And if I look at the cell prices, at the same time has gone down. So the cell prices are going to go down as the energy density keeps increasing. So tomorrow, if 400 watt hour per kg is going to be available, we are going to look at cell price closer to 75 or $80 per kilowatt hour. So this is the main driver. Today, lithium-ion battery is available up to 300 watt hour per kg. We are looking at 400 to 500 watt hour kg battery. LFP, on the other hand, LFP battery, some people use LFP battery. It is limited. Its upper limit is 160 watt hour per kg. So therefore, while it was an okay battery for yesteryears, for probably 3 years back, 4 years back, it is not okay today because the cost of LFP is not going to go down because the amount of material that it consumes is going to remain for every watt hour. It will continue to for every kg of material, it will only give you a 160 watt hour. So I've already pointed out that higher energy density will give you a higher safety concern. So overall, if I look at the EV cost with larger battery to overcome range anxiety, if I take, say, I want a 250 kilometer, 300 kilometer range for my car, it will be about 1.7 to 2 times, simply because of the battery cost. So either you have more expensive car, you can get subsidy or other things, or accept more expensive, or use lower sized battery. Now, when we look at India, we need to look a little more carefully. What is the India's auto market? If I look at it, 79% for our auto market for last few years has been two-wheelers. Then there is a three-wheelers like autos and all that. The economy class cars, which cost less than rupees 10 lakhs, most of us drive cars which are less than rupees 10 lakhs, is about 12%. And only 2% are the cars, number of vehicles are the cars which are above rupees 10 lakhs or 1 million. Buses and goods vehicle amount to 3%. So 95% of our vehicles will be characterized by affordable. And if I add the buses and large goods, it is a 98% of our vehicles are basically affordable vehicle. Simply because India has a limited amount of money, our people earn limited extent, they will like to buy vehicles which are affordable. And it is this which no other large country, the leaders in the world, United States, any of the European country, China, is more looking at higher end vehicles, whereas India looks at a lower end vehicles. So essentially, there is an opportunity for us to focus on the lower end vehicles, which is 98% of our 98% of our requirement, and the public vehicles, and become number one in that. That's where our focus has to be. Now, to really make, let's look at the energy efficiency of electric vehicles. As I pointed out, battery dominates the cost of electric vehicles. If you take the vehicles and if you look at higher energy efficiency, for example, if you start asking a question, kitna deti hai for electric vehicles? If you remember, this kitna deti hai was a slogan coined by Maruti, and basically it worked quite well because they were giving very high energy efficiency in terms of kilometers per liters of petrol. Now we need to actually talk about kilometers per kilowatt hour of battery, or in other words, watt hour per kilometer. Lower the watt hour per kilometer the vehicle uses, lower will be the size of the battery required to drive a certain range. So energy efficiency plays extremely important role. Size and weight of the battery reduces, in fact enhancing efficiency further. So over the last 3 to 4 years, one work that has been done, energy efficiency can be improved by better motor and controller efficiency. So essentially using a best motor and controller efficiency, using best possible tires and better vehicle aerodynamics and lower weight. What India has already done, and this is a very specific work that India has done, it has reduced the battery size required in, for example, two-wheelers and three-wheelers. In autos, for example, we are using today 45 to 50 watt hour per kilometer as opposed to 70 to 80 watt hour per kilometer that we used to use about 3 years back. Similarly, the buses are today because far more efficient, 900 watt hour per kilometer as opposed to 1600 watt hour per kilometer. What am I saying? I'm saying that if you work to improve the energy efficiency, you will make the vehicle more affordable. So it's about 35 to 40% cost of the battery can be reduced by actually improving the energy efficiency. So initially the cost used to be very high. Today, because it is 35 to 40% less size of battery that you're using, you are starting to come closer to what people can afford. What if you now need to go further? You actually can have two different approaches. The first approach that I will say is, if I look at the two-wheelers, three-wheelers, and the buses, which are public vehicles, what if I split the battery and start using small battery? Instead of using large battery, of course, large battery will give me no range anxiety. If I use small battery, one of the key concerns will be what will happen when the battery runs out, and battery can run out in relatively small distance now. Essentially, it will give you range anxiety. And it is here that we have come up with a situation that why not swap battery? Why not, instead of using a large battery and charge once it is over, you use smaller battery, and once you run out, you swap battery. You give away the battery that you have, take a fresh battery, charged battery. Why are we suggesting that? Because charging battery ideally should be done not less than 2 hours. Life of the battery depends on how slow you charge. If you charge in 2 hours or 3 hours, the life is good. If you try to charge it fast, there are ways you can charge it fast. Life of the battery is not good. So you definitely don't want to wait after driving a short distance for 2 hours or 3 hours. The swapping can be done in minutes. It doesn't take more than a few minutes to swap the battery. So what if you swap the battery? And so if a energy operator is available, separate the vehicle business with energy business, who actually supplies you, let's say on every street corner, battery which you can swap. So you just go there, give your battery and take a new battery, charged battery, and you can go on. Another advantage of this is that one of the big concerns is that in India, the temperatures go very high. It can go up to 45 degrees centigrade in summer. We will soon see 40 to 45 degrees centigrade. Now, if you charge the battery at high temperature, the battery get very badly impacted. What you like to do is that you would like to charge the battery at lower temperature. If you are swapping the battery, you don't need to actually charge it in at high speed. You can take away the battery that you have swapped out, you take it to an air-conditioned environment and swap it and charge it in about 2 to 3 hours, maybe in 3 hours, in which case you will get good life of the battery. So that overall will improve the economy of the electric vehicles. The second thing that you can do if you take larger vehicles, like let's say cars, like cars, or even I'll say two-wheeler. Now, you definitely do not want in a car to go every 50 kilometers and swap the battery. You don't want to swap. You typically fill a petrol once in 7 days. You like to therefore like to also charge maybe once in 7 days. What if you do any public charging once in 7 days? What if you decide to use a battery, which let's say for a car goes 100 kilometer, for a two-wheeler goes 50 kilometer? Now, how often do you drive in a day a car for more than 100 kilometers? You'll find most of the time you may drive 20, 30 kilometers, maybe 50 kilometers, maybe 70 to 80 kilometers. But rarely do you drive 100 kilometers, probably 5% or 10% of the time. So suppose you, and for a two-wheeler, you typically drive 20, 30, 40 kilometers. You don't typically drive longer than that. So what if you use a battery in a car, which is 100 kilometers, and in a two-wheeler, use about 50 kilometers? Then what you can do is that you can charge it overnight when you are at home, parking at home, and then you every day you have 100 kilometers of car ride or a 50 kilometers of two-wheeler ride possible. The day you need to go longer distance, and you know that today I'm going to go and need a longer distance, you go to one of these places which swap the battery, and they will give you an extra battery as a range extender battery. So you put two batteries in the vehicle only for that day. So you use now the battery that you have taken, and once you run out of it, use your own battery. You have, instead of 100 kilometer, you have a 200 kilometer range. And similarly for a two-wheeler, instead of 50 kilometer, you have a 100 kilometer range. And if you do need to drive more than 200 kilometers in a car, maybe swap it once again. Swap on the one is a fixed battery. Fixed battery is 100 kilometers, and you don't swap that. That is always there in the car. You charge it overnight. But a second battery, you keep swapping if required. Now, if you do that, you are actually buying a vehicle only with 100 kilometers, a car with 100 kilometers, or a two-wheeler with 50 kilometers. Suddenly, the vehicle will become highly, highly affordable. This two approaches of swapping can be used. Of course, if you are willing to pay more and you don't care about affordability, then you can buy a vehicle with 200 kilometer range or 300 kilometer range, and there is no issue. But only that will be purchased by only a small percentage of people, maybe 2 to 3% of people. Most of us will use a vehicle, purchase a vehicle which will be more affordable and will have a smaller range. Now, one of the big concerns that today, when we want to try to push electric vehicle, is that the current industry is all IC industry, vehicle industry, and auto sector contributes to almost 7.1% of our GDP, and our transport fuel processing, petrol processing and distribution is also 5% of GDP. So you have about 12.1% of GDP which depends on the current vehicles. So the question that is often asked is, the electric vehicle going to threaten all of that? And will we lose jobs and GDP? And today it will even become more relevant. The answer to the question will be, and that will be the second part of my talk, do we design and manufacture subsystems within India? If you design and manufacture batteries, if you design and manufacture cells, materials for the batteries, if you design and manufacture motors, charger, power converters, and vehicle management system, then we will have plenty of jobs and our GDP will only go up rather than going down. And we will not have to import the oil. Instead, we'll use electricity. So overall, the contribution of auto industry to GDP, when it's completely electric, can go up, provided we make batteries, cells, materials, motors, chargers, power converters, and vehicle management system in India, design and develop them. And so let me start with the batteries. What does battery pack consist of? A battery pack which goes into vehicle consists of three things: battery materials, which is 40% of the value; cell manufacturing, which adds about 25 to 30% of the value; and cell to pack manufacturing, which may be between 30 to even 40% of the value, depending on size of your battery. Now, let's start with battery pack design. This is already being done in India. Mobilytics said that it does it. There are many other companies which are doing it in India. The reason battery pack is being designed in India, because you need to design a battery which can withstand the Indian temperatures of 45 degrees centigrade. So the thermal design has to be done for Indian temperature and driving condition. So if you understand how to do thermal design, you can actually design a battery pack. You also need to do a very careful mechanical design, because the mechanical design is to ensure that the cells do not vibrate much, because the vibrating of the cells can give you bulges. If they are not firmly held, they will destroy the cells. And Indian roads are very rough, so we need to do mechanical design to ensure that they work very well. The third component that you will design in battery pack is the battery management system, which ensures that every cell gives you the best possible performance. And of course, safety is a major concern. It is a battery management system and battery pack design which actually handles the safety. This is 30 to 35%, maybe even 40% of the value, and is already being done in India. What about cell manufacturing? This is a tough one because technology changes every 2 years. We'll talk more about it. And finally, the battery materials, which is today mostly imported. Look at this slide. This gives you all the components that are involved, so many components that are involved in making a battery pack design. Huge number of components, something close to 120, 130 components, individual components that goes into battery pack. Cell is only one of the many components. Now, if you actually manufacture each of these components, and they're easily manufacturable, if you know how to design it well, they're easily manufacturable by all kinds of auto shops or other shops that exist, manufacturing shops that exist in India. You can create a large number of ancillary industry and large number of jobs. You need to design. If you don't design and develop but import all of this, then of course it will impact the GDP of India. What about the cell? India will need very large amount of cells, 100 gigawatt hour of cells, whether it's prismatic, pouch, and cylindrical. Battery cell manufacturing is a large chemical industry, process industry. And we have many process industry. For example, we have pharmaceutical industry, many other petroleum industry. It's all process industries. They are large plants, require high investment. Technology changes very rapidly, so you have to make sure that you bring in the right technology, and the cost falls very rapidly. So you really cannot have obsolete technology. This will also require a large number of ancillary industry. And if you really want to make cells in India, which can be a huge value add, there has to be some 10, 15 large process industry plant that has to be set up. This will be expensive plant. Typical plants may be almost 1,000 crore or 2,000 crore rupees plant. But there will be a large number of ancillary industry. And if we create that, we will not lose jobs. We will in fact increase the GDP. The third is materials. Lithium, cobalt, manganese, nickel, and graphite. Unfortunately, none of this we have in India. But we are using these batteries in cell phones, in laptops, and tomorrow more and more in electric vehicles. We have a large number of these batteries which become obsolete, becomes useless. They no longer are functioning. And what do we do today? Today we largely throw them away. Instead of throwing them away, if we recycle, it is possible to obtain 90 to 95% of the materials back. Lithium, cobalt, manganese, nickel, and graphite, 90 to 95% of the materials can be recovered and reused to make a fresh cell. So this is, of course, a tough industry. It's an industry which requires a lot of R&D to ensure that you recover it with zero pollutant, no air pollutant, no liquid pollutant, and no solid pollutant. But we have a large number of lithium ion batteries available today, and we'll have much larger tomorrow. We can actually, this is where the challenge is. A lot of youngsters can get into. And if we can develop these processes, I know one or two industries in India which have developed that, startups have developed this. This is a really, really good industry. And if we do this, we'll create huge number of jobs. Take, for example, a motors. Once again, a motor is required for a two-wheeler, three-wheeler, four-wheeler, bus, truck. Every vehicle will require a motor. And once again, you are looking at 60 to 70 individual components that make a motor. Again, these components are manufactured by ordinary manufacturing industries that exist in India. We, however, need to design these motors and controllers, and we need to then manufacture them. Today we are importing, most of it we are importing. We're just starting to make motors and controllers. This is what is going to push up our GDP. Finally, I will sort of say battery swapping. If we introduce battery swapping, if we start using smaller battery, let's say to begin with for two-wheelers and three-wheelers, and for four-wheeler as an add-on battery, as a range extender. I think, and if we have almost a kirana shop, a shop in every street or an alternate street, where we can give away our old batteries and take a new charged battery. This is very much like a swapping of LPG gas cylinder. I know nobody else in the world does this, but even LPG gas cylinder swapping is not done anywhere in the world. If we start doing this, we are going to create a large number of jobs, and that is what is going to make the whole industry thrive. So to conclude, I'll say today there is enough work that has gone on. The two-wheeler to three-wheeler can be made affordable in India. Four-wheelers will require a little more work. Maybe with range extender, you will see today the vehicles that are coming in the market are expensive. We need vehicles which are less than 10 lakhs. We need vehicles which are 5 lakhs rupees, and something like that will be possible. As youngsters, I'll say India needs to design and develop full EV drivetrain, battery packs, cell, recycle batteries to get the materials, motors, DC-DC converters, chargers, vehicle controllers, and of course, all kinds of vehicles. Time is of essence. If you do not do this, the Chinese vehicles are going to start flooding. Chinese components, battery packs, motors, chargers are already swapping us. But we need to really rise up, particularly after this COVID, make sure that we are not dependent on import, but do it in India. Can we do it by 2030? I think we can, and we have no option, because by that time, others will do it and they will flood us up. 10 years is a long time. I think we need to do it in the next 2 to 3 years. If you want to get more details, I have an article. I can share this to those who write to me. I will send you the slide deck. You can see this electrification magazine, IEEE electrification magazine. It's available at such and such URL. And I had written a blog almost 2 year and a half back, or almost 2 years back. That blog actually gets into many, many more details. And if you want to look at it, please go ahead and take a look at it. Thank you very much. That's my talk.
Thank you, Professor, for the presentation. It was very insightful and covered most of the EV value chain topics. So now we would proceed for the Q&A. We have received some question in registration page, and we are also taking question from the live chat. First question is from Viranji. What are the ways in which 2020 passed out engineers can be made industry ready? What are the ways to acquire required skill set for EV industry?
Well, I told you, what are take, for example, if you are a power electronics graduate. A power electronics graduate, you basically need to, you have learned whatever you need to learn. You need to get hands-on experience. You need to really be able to build things. As an R&D engineer, if you want to get into R&D, you need to be able to build things. Even a simple DC-DC converter, high energy efficient, will really help. If you are you need to be able to build motors, you need to be able to build controllers, you need to be able to build converters. As far as the vehicle management system is concerned, it requires basically a software and a simple embedded systems, which I think a large number of you will probably be able to train yourself fairly quickly. If you are a mechanical engineer and if you know your thermal designs and your mechanical designs well, there are all kinds of tools, you again can do well. These are the basic skills that you require. If you get into manufacturing industry, well, most of it, both the electrical engineers as electronics engineers as well as mechanical engineers will maybe preferred, because essentially it's like any other auto industry. I don't think, except battery manufacturing will be slightly different, but again, as a battery industry will largely assemble a battery and test the battery, and a motor will require a little more skills, motor industry, and you will see plenty of them. That's what you require.
Great. Second is about what is the future of EVs in India, because batteries mainly are imported from China, and
I
with
thought I
current.
answered that question. We need to make it today. We are already making packs. We can make cells tomorrow. We can make materials tomorrow. I think that's a, and therefore the imports, we have to just get rid of imports. I mean, when we started making IC engine vehicle, everything was imported. We started making everything in India. It's the same thing that we have to do, design and development. So going back to your first question, so it depends on whether you want to get into R&D industry. There is plenty of opportunity. If you want to get into manufacturing industry, basically all auto industry will convert themselves into electric in coming years.
Definitely, Professor. Second is what is the impact of social distancing on the electric three-wheeler and two-wheeler fleet or shared mobility industry?
Well, I think autos will continue. So look at the where is it being used. There is a company in Bangalore which, for example, gives you vehicle on hire, two-wheeler on hire. I think two-wheeler on hire and will not affect the social distancing can be done. Two-wheel on hire instead of purchasing two-wheeler. So that kind of industry will continue to work. When you are driving a two-wheeler and putting up one person in the back, that for some time is unlikely to work well. As far as three-wheelers are concerned, whether e-rickshaw or autos will continue to ply. Maybe they will have less number. Instead of putting 3 passengers in an auto, you may actually put 2. Instead of putting 4 or 5 passengers in an e-rickshaw, you may put 2 or 3. So otherwise, this will only increase the demand. I don't see any other problem.
Yeah, Professor. One interesting question we have got is that how we can penetrate the rural market.
Well, I think the two-wheelers will go to the rural market in no time. Two-wheelers and three-wheelers will go to the rural market in no times, because all that you really need to do is either battery swapping stations there or charging stations there. Once you start deploying them, that's an entrepreneur can set up a battery swapping industry, and then that can give, if you set up some battery swapping centers in whole, not one village, but or there are different people who put set up battery swapping and tie with each other. You need to really tie with each other. Then that will get the two-wheelers and three-wheelers in rural areas.
Definitely. One question is from Srinivasan. Recent reports suggest that increased growth for EVs, specifically in lower power ratings. What is your view on that, Professor?
In which, especially in which areas? For lower cost vehicles.
Yeah, I think.
Yeah, okay. Yes, obviously, I mentioned that two-wheeler and three-wheeler in next 3 years will be pretty much all electric.
Yeah.
I would say, but we would have seen this by beginning of 2023. whether it is going to become end of 2023, it depends on how COVID-19 plays out.
Yep. What are your views towards domestic manufacturing of lithium-ion batteries for?
I spoke about that. I spoke about that. I did talk about that there can be three kinds of industries. One is the recycling of lithium-ion batteries. The second is manufacturing of cells. These will be large chemical plants, process plants industry. And the third is battery pack manufacturing. So all these three has to be done in India. You can't just let it be imported.
Yep. One question is around battery swapping from Ashish. Why government do not provide support and subsidy for battery swapping?
Well, I think we try to push and get most of the things right in the policies. Sometimes governments don't provide the right policies. So they are, but though the people who operate vehicles, they actually buy vehicles along with the battery and use battery swapping. It has not prevented them from using that. There are enough industry which are today buy battery along with the vehicle, but and they get the subsidy and then they use it for swapping. Nothing prevents them. Unfortunately, I believe that the government should have just opened up. We had given all the suggestions. We had worked out everything. I was involved in drafting FAME 2 and all these policies. This is one thing that some industry did not allow it to be. When we try to do the uh, policies for electric vehicles, the established IC engine vehicle industry was dead opposed to it. They did not want this to happen. That is, they are putting all kinds of obstacles. Finally, government supported us and the obstacles could be removed. But they were able to put in saying that swapping will not be allowed. So, or swapping will not be supported. I won't say there is no provision made for supporting of swapping. Hopefully, this will change. This was supposed to have changed. I was told that this will be done before the end of the March, but then all these things happened.
Yep. One question from Dheeraj regarding financing, that how will the finance company help the EV businesses to grow in India?
So I think finance industry will give loans for electric vehicles as they are giving loans for IC engine vehicle. Just that it has to grow a bit. Today there is a little bit of uncertainty. We do not know what is the life of the vehicle. Somewhere the cost of the used vehicle is not well understood. I think over time this will be solved. Today we have very few vehicles still in the market. I think two-wheelers and three-wheelers will see the change happening over the next year and a half after opening up, and then we will not see any problem of financing. There are a few companies which are looking at setting up financing of two-wheelers and three-wheelers. Some of my colleagues have been, Dr. Prajot Kaur has been working with some companies which are looking at that. We'll have to wait and watch.
Interesting. One question from Tirupati Srinivasan. What type of changes in course curriculum are recommended in UG and PG streams to create a better resource for EV industry?
Well, I do teach a course on electric vehicle. All the recorded lectures are available, and again I will be doing that hopefully next August. Actually, it's a full course, so I actually teach most of the aspect. That material can be passed on to anybody who's looking at teaching this course, and people have to design the course appropriately.
A similar question around that what are the various sources from which I can upskill myself for the EV industry? So this is from one of the students.
I think one other thing that we should do, and I will probably take a lead, my colleague has been telling me, to actually offer short courses on electric vehicles. Once we start offering it regularly, because we do a fairly comprehensive end-to-end, and once we start doing that, hopefully there are others who will pick up and start offering this, and soon they will become a part of the college curriculum. I did see a few courses being offered here and there. One of the IITs was also offering some course. I found it on NPTEL. Actually, I found the course to be very theoretical. Didn't give you a practical idea and did not have anything which is likely to anything India specific. I think you need to give a course which is India specific. And my own, if my colleagues are here, some of them are attending this lecture. If they push us, and we should actually offer these courses. To begin with, and others can then take it up.
Great, Professor. Uh, One is from a startup called Isla Motors, Saurabh. How should a startup approach manufacturing lithium-ion cells in India, considering there is a high capital investment?
Yeah, lithium ion cells, frankly speaking, if you are not able to invest less than 1,000 crore rupees, you are not going to be viable. Let's remember the cost of EV cells drops down rapidly. Every 24 months, it becomes half of what it was, which basically means technology is changing and it is becoming higher energy density. If you are stuck with a technology which doesn't change, you will lose all of the money. So not only you have to have large investment, 1,000 crores. The reason you need to have a large investment, because even purchasing of the raw materials, lithium, manganese, cobalt, nickel, if you try to purchase in smaller quantity, the cost is very high. And if the cost of the raw materials is very high, your cost of your cells will become very high and nobody will purchase from you. So you need 1,000 crore rupees plus industry um, to set up. And I think there are companies which are interested. The large companies which will actually set that up as soon as the demand starts picking up. And we need to there are some small R&D going on in India. A little bit of technology exists in India, but to make something which is the state of art and to continue to be state of art, we may have to do a tie-up with some companies outside and then gradually develop our own R&D to make the next generation cells.
Great. Karun has asked that how about safety issues with electric vehicles? Can it cause any accident during rains or other calamities? Should we
So,
need a separate parking light lines for the EVs?
so I think the most important thing is the battery. As the energy density keeps on going up, batteries are like bombs. You are packing more and more energy in smaller and smaller volume and smaller weight. You're packing large amount of energy. And if anything goes wrong, it can get into trouble. Now, however, if you tell me that these batteries are worse than, remember that petrol has many more times higher energy density. If a smallest spark hits the petrol, the you will have the biggest fire. So it is less, is safer than the petrol. Except the battery, the current is always passing through, and this current itself can be the cause of heat, and the cells can be unevenly charged or can result into leaking cells. So this is where the battery management systems comes in, BMS. It is a job of the BMS and the battery pack design to ensure that the battery is safe. And therefore, battery pack is not just assembling cells. I think there are many people who believe it is just assembling. They are wrong. They are going to cause accidents. It requires huge amount of work. We have worked for last 3-4 years now. Or even now we are learning how to make safe battery packs. And I think you need to continue to do R&D to essentially make safe battery packs. Cells can be whatever they are. Cells can be higher energy density, but packs has to be safe. And this is where a very high quality BMS has to be designed.
Yes, Professor. One question around this topic only from Rahul, that paralleling lithium-ion batteries for EV applications have been a challenge. Do you see this to be happening in the future?
I don't know what the challenge is. I mean, frankly speaking, there are a number of people who are doing the designs, and manufacturing is not that difficult. Uh, Pack manufacturing is not that difficult. Pack manufacturing should scale up. The day demand picks up, the pack manufacturing will scale up. Now, FAME scheme makes it mandatory that if you want to utilize FAME scheme, you need to have battery manufactured in India. Once that becomes even more popular, you will soon see a lot of battery manufacturing in India.
Got it. One question from Karuna is that which type of battery chemistry is best suitable for Indian condition? Are there any raw material availability in the India?
So I did talk about raw material availability. We don't have raw materials, but we can recycle and get back the raw materials. That is the first thing that I mentioned. It's a separate industry. This needs to be set up. This is also a relatively larger industry, not 1,000 crore, but this also requires several hundred crore rupees. And there are some beginning being made. Now, this is as far as the raw materials is concerned. The second question was related to, what is the second part of this question?
Material availability in the India.
The material availability of second part. What was the first one?
Are there good batteries? What are the suggested chemistries for the lithium ion batteries?
No, frankly speaking, you want to see tomorrow's batteries are lower cost than today. Tomorrow's battery will be lower cost than today. If you and therefore you need batteries with higher and higher energy density. You start looking for cells which give you 250 watt hour per kg or more density. Today, there are only two kinds of cells which can give you more than 250 watt hour per kg. One is the NCA, another is NMC. LFP, for example, cannot give you more than 150 watt hour per kg. There is a dumping going on of LFP from China because they have overproduction, they have large plants which are closing down. Its own uses in China is not much there, so they are dumping it in India. But frankly speaking, their cost will not go down to $100, $95, $80, $75. So I will say use NMC and NCA.
Got it. Some questions are around battery recycling. That are there any financial incentives available for battery recycling plant in India?
I am told there is something in the process. Niti Aayog is working on something. I've seen those papers. Now it depends when it comes, but once things open up in several months from then, we will see some policies coming up supporting it.
Question from Ramanath Babu is that what do you think about the charging the battery using solar? Wouldn't that be a real renewable source?
Well, you see, what happens to solar? Today, solar is used, and either solar is utilized immediately or stored or put back into the grid. So if it is put back into the grid power that I get is a mix of solar and thermal. So I'm actually charging it already with solar. Now, over time, more and more solar will come up as more and more batteries are available. In fact, used batteries are available. Second use of the battery can actually go into the grid, and you will see more and more solar being used. So I don't think that, for example, if you use solar to charge the battery, the solar is only available in the daytime. What if you have to charge the battery in the evenings or the night? I don't think direct charging of battery with solar makes any sense.
One question is around the charging, that what about testing and certification agencies having capabilities to test and certify three-phase AC charging systems?
There is ARAI. There are about 5 or 6 agencies in the country which are now doing that. Offline, I can give you which are the organizations which are doing the testing and certification. I see a question on motors. Somebody is saying that I'm making BLDC motor. Now, my own suggestion is that BLDC motor is not going to go very far. BLDC motor basically is a motor which uses trapezoidal current. And something like this is not only less energy efficient, but also essentially gives you a what is called jerks. You try looking at permanent magnet synchronous PMSM motors. PMSM motors. The motors that are going to be useful tomorrow is PMSM motor. The BLTC motor will go out.
Certainly. I think we have done with the most of question. We can end with one question from RV Ranjan, that given the automobile industry in India is a big employer, including secondary place, will the government not give more impetus to the segment post COVID-19 at the cost of EV industry?
First of all, we need to understand what is post COVID-19. I think we have a limited understanding of post COVID-19. How much money government will have to do what, we don't know. By now, two-wheeler and three-wheeler industry will move to electric vehicle whether government supports it or not. It's already, the process is set. You'll soon see the electric ones doing better. I will say, look at our environment outside too. There is all the reason that we should actually promote electric vehicles. We should, because what has happened to this cities, towns, villages, what has happened to this earth? How much pollution have we been living? In fact, somebody told me the number of deaths, non-COVID-19 deaths in the country has reduced. Death rate has reduced. And I'll sort of say that the atmosphere in which we are living actually is killing tremendous number of people. So if we really clean our environment, it will really go a long way. I'll strongly recommend, and we will push government that support move to electric vehicle, support move to complete renewable or 80-90% renewable energy as early as possible. Let's get rid of this vehicular pollution and even a thermal plant pollution.
Yeah, Professor. So we are done with the most of the questions. People are asking for the presentation and recording of this session. So for presentation, you can write to the professor to get the PDFs of the presentation which professor shown in the webinar.
I am sending my email. Please send an email to me, telling who you are, and I'll send you the presentation. Ashok at tenet.res.in. I put it on the chat, so all of you have that. You can write to me. I'll send you the presentation. If you have questions, also you can write to me. I'll try to answer them.
Yep. And about the webinar recording, we will be also sharing that in the same emailer where you got your invitation for the webinar. With that, I think Professor has covered most of the questions either through the presentation or through the Q&A session. It was a really insightful session. Thank you, Professor, for arranging this session and giving your time for the community. We really appreciate your effort.
Thank you very much. But yeah, each of you can write to me, and I can certainly give you more information. Thank you. Thank you.
Thanks a lot. Thanks for all the participants.
Thank you. I see a lot of thank you. I wish I could see. Can I continue to see the chats for some time or no?
Yes, Professor. You can speak with the chat.
Yeah. Okay. Thank you very much. Thank you.